Fisher.
I'm Phoebe Altenhofen.
This is our accelerometer. So basically, what we did here is we first kind of looked up traditional ways to translate rotational to linear motion. And this is kind of the design we just decided on, with a wheel that translates the motion to an arm that then goes into a slot and peg here, and the peg's moving back and forth like that, and that's where the accelerometer's attached.
We thought that this would be like a good design because we thought that it would be easy to do analysis on, and so we knew the speed of our motor after we tested, and so then if we knew the speed of the motor, we knew that we would be able to then get equations for position, and then we knew that the max acceleration would be at either end of the peg in the slot, and then the acceleration would be 0 in the middle, and so we knew we'd get a nice sine wave out of it and be able to find the correct speed and the correct distances that our motor should run for getting exactly 1g of acceleration. We thought key concepts to this lab were obviously acceleration, but then not just acceleration, but understanding the relationships between position and velocity and acceleration, because it was really hard to find just a direct equation for acceleration coming from what we did know, which was the motor speed, and what we could calculate for and what we could do ourselves, which was like our radius and distances of our wheel. And so we found we found an equation for position, and then we're able to derive that twice to get our acceleration. Other key concepts were trigonometry, which we needed a lot of to be able to get our initial equations, and then also MATLAB and a good understanding of calculus.
Yep. Things that worked well with our design included its functionality, so it did translate the rotational motion to the linear motion like we expected. We did get it in a very close acceleration to 1g. It was just right under, showing that our calculations and predictions were relatively correct and did model the motion of it. And the reason for the slightly less than 1g of acceleration we expect was due to non-conservative forces such as friction and then a possible torque on the wheel. But in terms of the design itself, it was relatively easy to manufacture and stable, which was a plus considering there was not a lot of last-minute work to do on the design itself.
So for things that we could have improved on in our project, we became very close to the 1g acceleration mark, but we were just slightly under it. So that's something that we maybe could have improved upon if we'd done more trial and error, or perhaps found a way to incorporate that into our initial conditions and our equations in order to really actually hit that 1g. Another thing that we could have improved upon was you could see, especially at the beginning when we were showing the motion of it, but as our wheel turns, our accelerometer actually tilts this way, and so we were measuring our acceleration along the y-axis, but that means that as this was moving, our y-axis was also tilting, which caused a lot of variation within our acceleration wave when we were actually reading it. And so if maybe we had done this in a different plane, so if we had had our wheel this way, we could have measured the acceleration in a different axis that wouldn't have been changing during our rotation, and we would have gotten a more consistent and more accurate reading. Or we also possibly could have made this lever arm longer so that the angle just wouldn't have been so severe. However, we did need, based on our calculations, we needed this small of a radius in order to have the correct acceleration with our given motor speed.
So as an ending off point, here we have the math behind our design. First, we have a setup for our design, and then after finding the motor speed, we were able to find the theta of this angle in reference to the time, and then from that, we were able to use trig to find our position, and then from the position, we were able to derive it twice to get the acceleration, and that's how we found the acceleration for our design.